Hello, we are discussing about GATE 2004 ECE paper. For the circuit shown, which is RL circuit, find the current flowing through RL circuit when the input voltage is U of t. So we need to find the which is the correct waveform for the current I of t. Okay, input is given as U of t. U of t is a unit step signal. Unit step signal has a characteristic look like this. So unity magnitude is taking place at t is equal to 0. Before t is equal to 0, magnitude is 0. From t is equal to 0 onwards, unit step will have a constant value of 1 for any value of time. So that means there is a sudden change is taking place at t is equal to 0. At t is equal to 0, there is a sudden change takes place. But even though sudden changes are taking place in the voltage, no sudden changes taking place across the current flowing through this circuit, because the property of inductor is to stop, otherwise inductor doesn't allow instantaneous changes in the current flowing through it. So inductor doesn't allow any instantaneous changes in the current flowing through it. So inductor current at t is equal to 0 minus is equal to inductor current at t is equal to 0 plus, which is 0 amperes, because it has not mentioned the inductor current at t is equal to 0, so we are assuming that one initially uncharged. Inductor doesn't have any current. So IL of 0 minus is equal to IL of 0 plus, which is equal to 0 amperes. That we call it as initial value of inductor. Initial value of inductor. And as the current doesn't change suddenly, current changes exponentially. In inductor, current changes exponentially. So for any waveform which is changing exponentially, we can write the value at any instant of time by going through this equation. I of t, current flowing through any element, if it is changing exponentially, then at any instant of time I of t can be written as I of infinity plus I of 0 minus I of infinity into e power minus t by tau, where I of infinity is final value. I of infinity is I of t at t is equal to infinite, which is nothing but steady state. Under steady state, what is the current flowing through inductor? That is called as I of infinity. So we know that one under steady state. Okay. Under steady state, inductor acts as short circuit. So replace inductor with a short circuit, and there is only a resistor present, and we are applying 1 volts for this one. Unit step has the magnitude of 1, and this has 2 ohms. 2 ohms. So current flowing through it at t is equal to infinity. That is I infinity is equal to 1 volt divided by 2 ohms. So which is nothing but 0.5 amperes. So final value of the current is 0.5 amperes. Initial value is 0 amperes, and we need one more term, that is tau. Tau is time constant. Tau is time constant. For RL circuit, it is L by R. So L is given as 1 Henry and R is 2 ohms, which is nothing but 1 by 2 seconds. That is 0.5 seconds. Tau value is 0.5 and I infinity is 0.5 amperes. I of 0 is 0. Now you can express the current. I of t is equal to, okay, that is current flowing through inductor. I of t is equal to I of infinity, which is 0.5 plus I of 0 is 0 minus 0.5 into e power minus t by 0.5 seconds. 0.5 seconds. seconds. So now we can simplify that one. I of t is equal to 0.5 into 1 minus e power minus, okay, t by 0.5 seconds. So this is general expression, and we are going to find at t is equal to 0.5 seconds. For example, at t is equal to 0.5 seconds, what is the current value? Okay, t is equal to 0.5 seconds is nothing but 1 by 2 seconds. T is equal to 1 by 2 seconds, which is 0.5 seconds. So substitute I of 0.5, which is nothing but I of 1 by 2 is equal to 0.5 into 1 minus e power t is 0.5 divided by 0.5, so it will be minus 1. So this is equal to 0.5 into 0.632, 6.32. Okay, so this will be equal to 0.318. 0.318. So this is equal to, at t is equal to 1 by 2 seconds, current is reaching 0.318 volts. Current is, this is 0.0632. 0.318 volts. So the right answer is current changes exponentially. At t is equal to 1 by 2 seconds, current value is 0.318. So it is 0.31. The right answer for this question is C.